Welcome back. Let us continue with our previous lecture, that is chemical properties of carbonyl. This is our lecture number 5 on carbonyl compounds. Myself, Rakesh Singh, Associate Professor in Chemistry, Government Degree College, Union Territory of Jammu and Kashmir. Nucleophilic addition reactions were the reactions which we were studying in our previous video lecture. Reaction with ammonia derivatives. Aldehydes and ketones react with a number of ammonia derivatives in weakly acidic medium to form compounds containing C double bond N group. That is, when we treat carbonyl compounds with ammonia derivatives in weakly acidic medium, what happens? The C double bond O get replaced by C double bond N. What are the ammonia derivatives? Ammonia derivatives are those H of ammonia is replaced by some group, either OH, NH2, NHC6H5, NHCO, NH. If you understand the general mechanism, then it will be very easy for you to write all these reactions with ammonia derivatives. Let us first see the general mechanism. NH2 acting as nucleophile attack on carbonyl carbon with the displacement of this pi bond, and we get first addition. With carbon, we have two electron withdrawing groups. Dear students, आपने ये जरूर अपने प्रीवियस क्लासेस में पढ़ा होगा, टीचर्स ने आपको बताया होगा, whenever we have two OH groups attached to same carbon, they make each other unstable because of their Meinz effect, and ultimately there is loss of, and we get zero. Same situation is here. The only difference is that in place of OH we have NH on one side. Again here, in presence of acid will catalyze it. There is loss of water, and C double bond O get replaced by C double bond N in the final. That is why we call it nucleophilic addition reaction followed by elimination of molecule of water. पहले nucleophilic addition हुआ, फिर removal of water, minus water. Let us further elaborate this reaction. We said that in weakly acidic medium, if the conditions of the reactions are not controlled, then it is not possible to achieve the reaction which we want to achieve. Control of pH is very important in this reaction during addition of ammonia derivative. The addition of ammonia derivative to carbonyl group of aldehydes and ketone is catalyzed by acid. In acidic medium, the oxygen atom of carbonyl group gets protonated, which by resonance increases positive charge on carbonyl carbon. Mean like it get protonated, and hence it increases the positive charge on carbonyl carbon. As a result, big nucleophile like ammonia derivative readily attacks on the carbonyl. During the course of reaction, it is necessary to control pH of reaction, because in case medium is too acidic, the ammonia derivative being basic also get protonated, also forms their respective ammonia salt, and hence cannot act as nucleophile. It's very important. If we make the condition too much acidic, what will happen? The acidic condition will protonate the ammonia derivative also, form its ammonium salt, hence reaction will not occur. However, if medium is only very slightly acidic, अगर हम acidity बहुत कम कर देते हैं, the protonation of carbonyl group will not occur. फिर carbonyl group का protonation भी नहीं होगा जो हम चाहते हैं. Why we want the protonation of carbonyl group? हम क्यों चाहते हैं इसका protonation? So as to increase the positive charge on carbon. ऑक्सीजन के ऊपर जब पॉजिटिव चार्ज आएगा, it will withdraw the pi electron more strongly from the carbonyl carbon and make it more positive. so that even big nucleophile can attack on carbonyl carbon, like ammonia derivative. That is why we want protonation of carbonyl carbon. अगर हम मीडियम को लेस एसिडिक कर देते हैं तो उस केस में भी रिएक्शन नहीं होगा, तो कार्बोनाइल ग्रुप का प्रोटोनेशन नहीं होगा. व्हाट इज द ऑप्टिमम पीएच? 3.5. 3.5 pH should be maintained during the course of reaction to get best results. Nucleophilic addition of ammonia derivatives. Carbonyl group. First step is protonation, pH 3.5. This is the detailed mechanism. First step में protonation होगा carbonyl group का, and we get this. This is Rayonian structure, and from the Rayonian structure it is clear that because of protonation, the positive charge on carbonyl carbon has increased to great extent. Now it gets attacked by the nucleophile ammonia derivative, and we get. We are writing the mechanism. Every step has to be written. So when you attack, nitrogen acquire positive charge. To neutralize itself, nitrogen will lose H positive from this NHG. मैं ऐसे लिख लेता हूँ H यहाँ कंक्लूजन क्रिएट NHG ये बन गया. Now in presence of acid catalyze करेगा acid इसको, it is loss of water and we get the final. हमें क्या मिलेगा? Final is loss of. अब हम G मैंने पहले बताया आप, what is G? Either OH. If it is OH, it is hydroxyl. If it is NH2, it is hydrazine. If it is NHCCH5, phenyl hydrazine. If it is NHCONH2, it is semi-carbazide. So let us discuss these reactions now one by one. Mechanism journal हमने discuss कर दिया. Now we will study these reactions one by one. इन्हीं reactions को हमने ये यहाँ पे one by one explain किया है. Same reactions. First reaction with hydroxyl NH2OH. E is OH. अब हमने one step में लिखना. General mechanism आपने explain कर देना. Then you can write in one step. In one step, you know, in the end there is loss of water. Loss of water occur, and we get oxide as the final product. Formaldehyde, formaldehyde oxide. Acetaldehyde, acetaldehyde oxide. Acetone, acetone oxide. Loss of water. Ultimately, there is loss of water. You go to the previous reaction. फिर से आपको दिखाना चाहूंगा so that there is no doubt left. What happens? Serial bond O get replaced by serial bond. There is loss of water. Same formula we are applying here. Loss of water, serial bond O get replaced by serial bond. We are writing the final product. General mechanism we have written. Every step we have written. So this is addition of hydroxylamine NH2OH. Always write it like this. NH2OH. आप इसको बच्चे ऐसे लिखिएगा. यहाँ पे तो हमने ऐसे लिखा NH2 is at the base. Now next addition of phenyl hydrazine. Same formula we have to apply. Addition of hydrazine, phenyl hydrazine. In phenyl hydrazine, what we have done? First, I wanted to discuss with you addition of hydrazine, 2,4-dinitro, carbazide. Addition of hydrazine. First, I wanted to discuss with you addition of hydrazine. What is hydrazine? In place of this, you have to write NH2, NH2, hydrazine. NH2, NH2. Mean no phenyl hydrazine. Again, there is loss of water, and we get the product which is hydrazone. In this case, if you use the hydrazine, you get hydrazone. N double bond and NH2, loss of water. ये बच्चे याद. We have missed that slide. I am explaining to you. When we treat aldehydes or ketone with hydrazine, conditions are same. We get hydrazone. If it is formaldehyde, we get formaldehyde hydrazone. If it is acetaldehyde, we get acetaldehyde hydrazone. If it is acetone, we get acetone hydrazone. Again, I would like to explain to you. For example, we write any aldehyde, we treat it with hydrazine. there is loss of water. And what is the product? The product is C double bond N NH2. We get hydrogen. Aldehyde, formaldehyde, formaldehyde hydrazine, methanol hydrazine, IUPAC name लिखना हो. Acetaldehyde hydrazone. Hydrazone. Hydrazine gives hydrazone. So it is acetaldehyde hydrazone, acetone hydrazone. Now next is reaction with phenyl hydrazine. The difference between hydrazine and phenyl hydrazine is that in case of phenyl hydrazine, the one H of the NH2 is replaced by phenyl. This is phenyl hydrazine. And the end product is phenyl hydrazone. Hydrazine gives hydrazone, phenyl hydrazine gives phenyl hydrazone. Reaction is same, loss of water. We get phenyl hydrazine. If we take formaldehyde, it is formaldehyde phenyl hydrazone or methanol, IUPAC name लिखा है. Acetaldehyde, acetaldehyde phenyl hydrazone or ethanol, IUPAC name लिखा है, phenyl hydrazone. Acetone, acetone phenyl hydrazone or propanone, 1, 2, 3, propanone phenyl hydrazone. The reaction with what? Reaction with phenyl hydrazine and phenyl hydrazine. Both are similar reactions. There is difference of only one substituent. That is in case of phenyl hydrazine, we have phenyl group attached to the hydrazine. Next, reaction with 2,4-DNP, 2,4-dinitrophenyl hydrazine. एक स्टेप और आगे चलेंगे हम. 2,4-dinitrophenyl hydrazine मतलब फिनाइल के ऊपर at second numbering यहाँ से है, at second and fourth we have nitro group. This is also called Brady's region. What is the product? Product is 2,4-dinitrophenyl hydrazone. Hydrazine, we get hydrazone. In case of phenyl hydrazine, we get phenyl hydrazone. In case of 2,4-dinitrophenyl hydrazine, we get 2,4-dinitrophenyl hydrazone. Orange or red precipitates of this compound are. Reactions are same. Formaldehyde, loss of water. Methanol 2,4-dinitrophenyl hydrazone. Ethanol 2,4-dinitrophenyl hydrazone. Acetone 2,4-dinitrophenyl hydrazone. Orange or red precipitates of 2,4-DNP hydrazoles are formed in this reaction. Similarly, next is reaction with semi-carbazole. So this is very interesting. We have NH2, NH, CO, NH2. Now, if you see this compound, it has NH2 on two sides. Now, which NH2 can act as better nucleophile? This one or this one? This one. This one not. Why? Because this lone pair is involved in triangle. अगर आप एग्जाम में इधर से रिएक्शन करके आ जाते हैं गलत हो गए. You must understand. This lone pair, this NH2 lone pair is in rivalence. It is not available for acting as nucleophile. So that is why we have written reaction from NH to NH side. It can act as nucleophile. Loss of water, and we get what? Semi-carbazole. Semi-carbazide gives semi-carbazole. Always write it like this: NH2, NH, CO, NH2. This is the correct representation. It is semi-carbazole. If you take formaldehyde, methanol is the IUPAC name. You can write formaldehyde semi-carbazole or methanol semi-carbazole. Acetaldehyde semi-carbazole or ethanol semi-carbazole. Acetone semi-carbazole or propanone semi-carbazole. So semi-carbazide gives semi-carbazole. Next is reaction with ammonia itself. Earlier we studied ammonia derivative. Now it is ammonia itself. Ammonia के साथ बच्चे हमने reaction देखा. Ammonia react with aldehydes other than formaldehyde react with ammonia to form aldehyde ammonia adduct. This is adduct. Which upon heating, आप इसको heat करें, lose water, HOH. Electron withdrawing groups हैं दोनों एक दूसरे को unstable कर रहे, lose water to form LD-amine. Est LD imine. Imine कहते हैं C double bond NH. Is single bond NH2 amine, AMI. It is imine. So first point, important point, aldehydes other than formaldehyde, when treated with ammonia, they form aldehyde ammonia adduct addition product which upon heating lose water to form aldehyde. Formaldehyde react with ammonia to form hexamethylene tetramine, which is used as a urinary antiseptic as well as in development of RDX, research and development explosive. RDX बनाने में भी इसका इस्तेमाल होता है. Nitration of this compound, hexamethylene tetramine, gives RDX. Urinary antiseptic के तौर पे भी इसको इस्तेमाल करते हैं as medicine. Urotropin इसका नाम है under the name. In the law, one is aldehyde other than formaldehyde. Formaldehyde react to form hexamethylene tetramine. And acetone react with ammonia to form first addition product. पहले बची addition product. जैसे यहाँ पे नाम में गलती है. We will correct it. Acetaldehyde. We have written aldehydes other than formaldehyde. So it is acetaldehyde. Acetaldehyde is other than formaldehyde. Formaldehyde reaction is this. So acetaldehyde and formaldehyde and acetone. First step is same as that of acetaldehyde. First step is same. The addition product formed again react with acetone. जो addition product बनता है वो फिर react कर जाता है acetone से and form diacetonamine. मैं इसको simplify कर देता हूँ आपके लिए. With loss of water यहाँ से and gives diacetone. तो खुद वाटर लूज करने के बजाय एसीटोन से रिएक्ट कर जाता है एक और मॉलिक्यूल से एंड फॉर्म डाइएसीटोनमीन माइनस वाटर प्लस वाटर. डाई दो मॉलिक्यूल एसीटोन के साथ में क्या है बच्चे वी गेट डाइएसीटोन. दिस वाज रिएक्शन विद अमोनिया इटसेल्फ. अमोनिया रिएक्ट विद, इससे याद रखिए बच्चे, अमोनिया रिएक्ट विद डिफरेंट कंपाउंड्स अंडर different compounds to give different products. With aldehydes other than formaldehyde, it gives acetaldehyde. With formaldehyde, it gives hexamethylene tetramine, and with acetone, it gives diacetonamine. This is acetaldehyde. This is acetaldehyde, not formaldehyde. Acetaldehyde. Thanks. So this was all about reaction with ammonia derivatives as well as reaction with ammonia. This is my WhatsApp number. Regarding any doubt about this video lecture, you can WhatsApp me on my mobile number. Thank you. Thank you very much.